All right, welcome back. Let's add a new feature to our kind of shader playground here, which is that we will add, we'll assume there is a uniform called time in every shader, and we'll set that um, with the like current time or whatever, some kind of time, so it like progresses, and we can easily use that for animations inside the shader. So actually here in our like default shader, we should probably have that added in float time, and maybe we can even use that here. So we use it in some kind of sine function, and that goes from -1 to 1. So maybe we say like +1 and then divided by 2. It goes from 0 to 1. All right, but now we should figure out how to set it. How to set it. So we have the apply button, and we just call this function apply uniforms, which does this kind of thing. So we simply have to have something like that. That's called like set time. Maybe we'll also take mutable self, and we can copy paste this to make our life easier. So if we have a shader, we might get a message, and what we will try to do is this. Set uniform value, this context, what is the name of the uniform? Well, it's just time. What's the value? That is a good question. So maybe we'll just take it for now as a time like that. And what is the type? So we had some kind of uniform type float. So it's that. And if there is a message, if there's some kind of error message, we will simply report that. We can get rid of that. We don't need that. And great. Now we just need to set the time. And we can do that in the bottom here, I guess. This function is there. Okay, great. So it's kind of a weird way to get the time, but you have to do like UI input I.time, and then I think that's how you do it. We don't have a UI here, which is interesting. So we need to find the central panel actually, which is this one. Okay. So here we can say set time uniform, and there we go. Now we have it. So we have some time. It's an F64, but we want it as an F32. And then we can say set time with this time. I think that's it. That should be it. So let's make a new project, and we'll call it time test. So it's compiling, compiling. And here we go. And we can even see it changing. So let's open up the project, time test. And we have it changing kind of not very smoothly. So I think what I would like to do is actually change how often we update. So let's actually set it to update 60 times a second. And of course, it's not really gonna work until we restart. So let's restart. So now it's, I'm not sure it's coming through in the recording, but now it's a lot smoother. So actually what we can do is we can, let's say we have a function like y equals f of x. We can actually plot that by doing something like 1 divided by let's say 1 plus the absolute value of y minus f of x. So let's try that with y equals, let's say sine of x. Why not? So we have some kind of value, which is going to be the brightness, and that's equal to this formula. So we're going to say position y minus sine of position x. And then let's just comment this out. We can put that in here, brightness. Let's make it vector 3 and then like that. So I think, yeah, I hope you can kind of see it, and we can make it, I think, fall off faster if we do like that and like that. Yeah, so we have like an extra factor which we'll call it's called the control factor. I'm not sure what to call it, but if that's small, then it's very narrow, the function we're plotting, and if it's large, it becomes wider. So we can make it super sharp like this. And let's change the function. Let's make it vary a little bit faster. So like times 3, and we can even times 30. Okay, that's a little bit too much, but like that. Times 3, and maybe just make it a bit more compact. I like that. That looks good. All right. We do get a message like uniform time could not be found. That's because we're not using it, and that means it's kind of like automatically removed during the compilation, because it makes a lot of sense. All right, so what we can do now is we can even, let's put the time in here and see what happens. So because the time is such a large number, you get this kind of weird pattern. But what if we do cosine of time? Then we should see it kind of animate like that. Nice. We can also do, so we had like a 3, let's say. We can also do something like this, plus time, and we get it kind of moving, and we can speed it up and stuff like that. So now we have this like very easy way to do animations, and I'm wondering if we should do something interesting with that. I should try to do something interesting with that. I don't really have a good idea, but let's just try some stuff. So we have the position, and let's try, I think there's a function called fract, like for the fractional part. Then here we just use p instead. And okay, if you do that, you get this kind of thing. And then we can even like multiply it by 4. I think that should give us even more parts. But what's happening is now we're only seeing like part of everything. So maybe, what if we multiply by like 2 here? Or no, let's just do this. And let's do p of x is the fractional part of g of x. And we get this thing. So now we should only have numbers from like 0 to 1. So what we can do is we can say p of y times 2. And also like we multiply by 2, and we kind of have to subtract 1, I think. So now we're back in the original kind of frame of view, almost. Because if we also do, we should also do the same with this. Now we have exactly the same thing. So if we comment this out, it should be just 1. If we do that, it's 4 copies. So can we generalize this so we kind of repeat something many times? Yes, I think we can just do this. I is less than 3. Let's not go too crazy. We do all of this stuff, like we repeat that. So maybe we can even make that a function like let's call it repeat pattern, and it takes the original position and it takes a number of times, and then it just does this thing. And we should also return few. And then this one we can just say, okay, it's actually repeat whatever pattern we have 3 times. It's not really 3 times, it's like how many times you divide it. So if you put 3, you get 8 by 8 because you divide it by 2 3 times. And that is that. Can we do some more stuff now? So maybe this is instead going to be, let's try to make some other kind of function. What could we do? What could we do? I have a couple of helper functions in here. Maybe we grab those. And then we can like say, okay, brightness plus a Gaussian, and what did I just do? Thought I copied them. So like that. Now brightness. Okay, so we have the Gaussian, which takes position, location of the Gaussian, and some standard deviation. So we can, maybe let's try to multiply by a Gaussian located at 0, 0. No, sorry, you need to provide the position, and it's located at 0, 0. And maybe it's a little bit like elongated like that. So that makes this kind of pattern, and looks kind of cool. Looks kind of cool. Maybe we don't divide it so many times. For some reason it's not updating. It's because we're not using the times here. There we go. All right. What else could we do? I think I'm gonna experiment a little bit off screen because it doesn't make sense for you guys to see me here like not knowing what the hell to do. So I'll see you in a little bit. All right, after playing around a bit, this is the best I could come up with. I am clearly no artist, but at least it's a little bit interesting. And we can even do something like this. If we don't want to look at the animation necessarily, we can say uniform float time. And now it's 0, but then we can go ahead and add a uniform controller. Chosen time, let's say it goes from -100 to 100 as usual. And we can kind of find the best time, like where the animation is interesting looking. Let's actually get rid of it and say chosen time, and we'll just have it between 0 and 1. I think that's all right. It lets me have a little bit more fine-grained control. And that was actually not good enough, so we have to do it again. So this is something that's a little bit annoying, honestly. Maybe we should implement a better way to handle like editing uniform controls. but there it is. So you can kind of see the different stages here they go through. Maybe if we don't do this, so they kind of activate at the same time. Like that. All right, that's gonna do it for this video. I will see you in the next one. Bye bye.